Action. Okay, guys. We're gonna have a great class today. Guess what we're gonna talk about? Stopwatch. No, we're gonna talk about waves. We're gonna talk about waves all week long. Okay, I need a volunteer. Me. Okay, Devlin. Or Justin. Sit down in the chair. I think you guys are a little close. Scoot back a little bit. Okay. No, rotate the chair sideways. Like this. Tie this around here.
Please.
I want you to tie
I
it.
need dictionary because my English is not good. Your English is very good. You're good at English. But I. Please.
There we go. Okay.
Please.
Who's gonna be my timekeeper?
Timekeeper.
Timekeeper?
Timekeeper.
Okay. All right. So let me show you how this works. Okay. So there are 30 seconds all the way around. And notice there's a red and white alternating on the smaller stuff. Right? So the one is 1 minute. So it comes around, that's 30 seconds. It comes around the second time, that's a whole, you count it for 31, 33, comes around. So twice around is 1 minute. But we really aren't going to go that far. We're only going to go maybe 10 seconds, maybe 16 seconds. So what we're going to do is you need to come up close. Oh, did it not? Okay. What we're going to do is we're going to calculate the wave speed. Wave speed of the rope. Now you remember two things that I talked about wave speed, right? So if I don't have any tension, right, and I just send a wave down there, it goes pretty fast, right? But if I have some tension, right? I don't know if I have some tension, then it goes much faster, right?
Yeah.
You see how it goes down and back? Okay?
Yeah.
So I have to have a little bit of tension here, and Justin, I don't want you to fall over, so I'm gonna pull pretty hard. Are you okay? You okay? Okay. All right. So what I'm gonna do, don't worry about starting yet. I'm gonna first explain some things. Okay. So I'm gonna create. This is what we call a fundamental, right? And I have to keep the same distance. What I'm trying to do is keep, and you have to make sure to make sure you keep this right on this line. You see this line? Make sure your chair does not move. Okay? Because we're going to measure that distance. Okay? And I'm going to try and keep it right at the door edge. Okay? So we have the same distance the whole time, but I'm going to put it at this point. Yeah, we're good. Okay. Are you ready?
Yeah.
So first, we're going to count. What I want you to do, Jay, is I'm going to get it going, and then what you're going to do is you're going to start it, and you're going to count 30 cycles. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? When I get to 30, you stop.
Okay.
Okay, but I'm going to keep going. And then you're going to say that number. So wait until I get going, and then I'll tell you to stop. Start. Actually, we're going to calculate for this. Wait, move your foot. So we're going to do. Is it harder to count those? Or do you think it'll be easier to count fundamental? Let's go ahead and count fundamental. Okay. Alright. I'll tell you when I'm ready. Okay, I'm ready. Okay. What we get? So basically 12 seconds for 30. So where's my marker? Okay, guys, remember the equation for speed and wavelength and frequency?
Speed equals to frequency times wavelength.
Okay. So the frequency is equal to how many times did you count? 30? 30 per 12 seconds?
Yeah.
So what's the frequency? About 3 times per second? Ish? A little bit less than 3 times per second? I think I was going slower than normal, but normally I can go 3 times per second.
2.5.
So I'm going to try and go a little bit faster and make sure it's 10 per second. That way we get 3 hertz, okay? Because that makes it the math easier. Are you guys good with that?
Okay.
3 hertz? Okay.
Yeah.
So now what we got to do is measure the wave length. Now, here's the question. If I'm out here with fundamental, right?
Yeah.
How far is this? Is this 1 wave, half a wave, 2 waves? What is this?
1 wave.
This is half a wave.
What?
This is only half a wave. Because you measure from peak to peak, right?
Oh
So
yeah.
this would be a full wavelength.
Oh yeah.
Yeah? Right? This is a full wavelength. Yeah. Go ahead.
Social and Zhang Wen.
Oh, I do.
Okay. Take care. You can just set it on the table.
Okay.
Okay.
Now we need a
So
new
you-
one.
What?
Now we need a new one.
Oh, no, that's okay. We got the values that we wanted. But now, actually, I do need another volunteer. Frank, can you go over and grab that tape measure? The tape measure. The tape measure. The tape measure, not the timer. No, the round one. Yeah, okay. So what you're going to do is you're going to measure here. And actually, you're going to hold this, Justin. Can you hold this? Okay. Okay, come on here. So 7 meters. That's nice. Okay, you can roll it up. So half the wave. Oh, sorry. I didn't mean to step on your collar. Half the wave. So this is half. Is equal to 7 meters, right? So what's the wave speed?
Wave speed.
You can go get your calculator and come back and sit down. Because I'm going to need you to demonstrate some more stuff. 52. 52 what? 52 meters per second. Okay, so wavelength is 14 meters, right? Okay, so wave speed is going to be 14 times 3.
42.
42
Oh, 40.
meters per second. So what does that mean, 42 meters per second? So that means that this wave, when I send it down there, that's how fast it's going.
Wow.
42 meters per second. That's pretty cool, right? That we were able to measure the speed of the wave from those two things, okay? So now, if we have a constant wave speed, because I have a constant tension, I'm not going to pull it tight or loosen it. You guys should be able to calculate the frequency based on changing the wavelength, right?
Yeah.
So, if the wavelength is 14 meters, and now the wavelength is 7 meters, what's the frequency?
Will be half.
Twice.
6.
6 hertz. 1, 2, 6 times per second. Does this look like 6 times per second? 1, 2, 3, 4, 5, 6. Maybe it's 1, 2. How long is a second? 1,
2, 3, 4, 5,
my arm's getting tired.
7.
Okay, so now I'm gonna try and make it 9 hertz. So 9 hertz would be what wavelength?
3. No.
If I have 9 hertz, what's the wavelength?
14 divided by 3.
I didn't want that.
4.67. Wow.
My arm's tired. This is 9 times per second, guys.
在震动。
Okay. All right, now I'm gonna try and go. What's the next one? 12 hertz.
Yeah.
Okay, you ready? Ugh. I can't do it. My arm's tired. demonstrate? I feel like sometimes we need to demonstrate, like in real life, so you guys get the concept of wave speed, wavelength, and frequency, and how they're all related. So yesterday, I pulled out my phone, and I tried to listen to the radio station. Not all of you guys are here. And we turned the radio station to 107.7. Okay. 107.7. And does anybody know what that number means?
No.
Frequency, okay.
Like
107 what? Megahertz.
Yeah, mega.
Right. So megahertz, how much is a hertz? Or how much is mega?
1 million.
1 million. So this is 100. So I was going to write it out 107.70000 hertz. All right.
Yeah.
So what else do we know about this? Could we figure out the wavelength from this?
Yeah.
What's the speed? 299.792.458 meters per second. Or 3 times 10 to the 8 if you're happy, if you're rounding up. So please give me the wavelength. How much you get? 2.78. 7.8. What's the unit? Meters. Okay, 2.78 meters. Wait, don't go away, Justin. Hold this. We're gonna just kind of, we want to see how far that is. So that's 2 point, basically right there. Okay.
That's not.
What?
That's short.
Yeah, that's not very long, but I mean, it's going the speed of light, right? Now here's the thing. When I tried to listen to it, it wouldn't let me listen to it. Do you remember what the message was?
You need to plug in there.
They asked you to plug in the earphones because it also serves as an antenna. Because the wire in the microphone, in the earplugs, is a metal wire. And the radio wave goes past the wire and gives it a charge. Of course, my earphones are not this long, but it's able to pick it up, the charge, enough, that it's gives you the signal. That's pretty cool, huh? Now, here's the question. We did this yesterday, for those of you that weren't here. If I don't need the earphones for normal times, normally, what do you think the frequency is to, the phone's not very big, right? But we, send messages, we can call on it, so how big do you think the antenna is right now? Not very big, right?
Yeah.
So if it's not very big, what do you think the wavelength might have to be?
What?
Maybe, I have no idea, but let's just throw out some numbers here. I'm guessing
1 meter.
maybe, oh no, smaller than that. I'm thinking it has to be maybe, 5 centimeters.
Wow.
That's probably really short, but maybe it's higher than that. But if it's 5 centimeters, please tell me the frequency. Alright, so if the wavelength is 5 centimeters, so that's 0.05 meters, what's the frequency?
G.
599.859.6.
So 6 gigahertz. 6 gigahertz. So that's what they call, that's not quite microwave, that's still considered a radio wave, but it's like really short, really high frequency radio wave. Yeah. Anyway, I'm going to stop the recording now just because I wanted to
some demonstration, but we're gonna move on to